Okay, so we are going to start a brand new unit today. We are in unit 3.1. Okay, and today is going to be all about factoring review. Now, you have done everything that we will do today, okay? Today is 100% review, okay? It is all factoring review. Now, whether or not you remember that may be a different story, so that is why we are going to do this review. Okay, so when we are factoring, the first step in factoring, does anyone remember what is the first step in factoring? Okay, factoring steps. First thing you always want to do is look for GCF. Does anyone know what is a GCF? Okay, what does greatest common factor mean? The greatest common factor is the greatest thing that every part has in common. So the biggest thing or biggest factor, biggest component, how would we like to say that? Biggest term that all terms have in common. Or sorry, let's go biggest thing. I changed my mind. Sorry. Biggest thing that all terms have. Okay, that's always step one. You are always going to look for a greatest common factor first. Okay, step two is you want to count the number of terms. Count number of terms. Okay, now, when you count the number of terms, there is either going to be 2 terms, there could be 3 terms, or there could be 4 terms. So count up the number of terms. And then depending upon how many terms there are a couple of different types of factoring that you could do. Okay, if you only have 2 terms, the only kind of factoring you could do is something called difference of squares. Difference of squares. Or something that we call SOAP factoring. SOAP or cubes factoring. Okay. Now, you may not know all of these types of factoring yet, but this is kind of your general flow chart that you would follow. Okay, so 2 terms is either going to be difference of squares and then either SOAP or cube factoring. 3 terms, sorry I'm running into things, 3 terms has to be trinomial factoring. Okay, some of you guys might know that as diamond factoring. Okay, but that's actually technically called trinomial factoring. And if you have 4 terms, does anyone know what that's called if you have 4 terms?
Quad factoring.
It's grouping.
Oh.
But nice try with the quad. So that's your general plan here, okay? Is to first try to look for GCF, and then second, try to figure out what type of factoring we can do. Okay, so to start with, let's just first off, your instructions are always going to say factor completely. So a lot of times that means that you will have to factor more than once. Okay, it could be factoring 2 or 3 times even. Okay, so factor completely. For example, number 1. If I ask you to factor completely 12x squared y cubed minus 20x cubed y squared. Factor completely 12x squared y cubed minus 20x cubed y squared. Again, the first thing you want to look for is a GCF. And GCF is the biggest thing that both terms or all the terms have in common. So first you want to look at the numbers. What's the biggest number that could go into both 12 and 20?
4.
4. Okay, so we know we're going to be able to take out a 4. How about the x squared? What's the biggest amount of x's I could take out of both? 2. So x squared, because that's the largest one that they have in common. And then if you look at the y's, what's the biggest number of y's that they have in common? 2. So y to the second. Does anyone not see why this would be the GCF? Did I confuse anyone with why that would be the greatest common factor? Yes.
I'm kind of confused.
Okay. Basically, if you wrote this out, and I'm not asking you to do this, okay? Do you understand how out of 12 and 20, the biggest number that would come out is 4.
The biggest number that's in common.
That goes into both of them, yeah. The biggest number that they have in common. Do you understand that? Did I get you confused on the x part? Okay, the x part is x squared is really x times x, right? Y cubed is really 1, 2, 3 y's. Here, this is really 3 x's and 2 y's. So you're basically figuring out how many do they have in common? How can I take out of both? So here, I know I could take 1 x out of each, and they still have more, so I could take another x out of each. Then, that's what they have in common, so that's why I wrote x squared here. The y's, you would do the same thing. I know I could take out 1 out of each, and then I could take out another 1 out of each. That's how you figure out the largest thing that they have in common. Then what's left behind is after you divide these away, what would be left behind? So if I divided away a 4 out of 12, what would be left behind?
3.
A 3. And then would any x's be left behind? No, because I divided them away. Would any y's be left behind? 1 y. Minus, if I divided away 4 out of 20, what would be left behind? 5. Would there be any x's left? 1 x would be left. Would there be any y's left? No. That's your answer. Now, I know that you guys might be a little rusty on this. You might not remember it 100% right now, but you will start remembering it, okay? It will come back to you. It's kind of like riding a bike, okay? You might stumble a little at the beginning, but you will remember again how to factor. So GCF is just figuring out what's the biggest thing that all the parts have in common, and then you divide it away so it goes on the outside, and whatever's left behind is in your parentheses. Okay, so this is your answer. That is completely factored. Let's try another one. Number 2. Say it again. Okay. Number 2, if I want you to factor x squared minus 4. X squared minus 4. Factor x squared minus 4. First thing you want to look for is GCF. Is there anything that both of these have in common? No, there's nothing that they both have. Then if we look at our chart, it has 2 terms, so 2 parts. Is this difference of squares? How can you tell if this would be difference of squares?
They would both be squared.
Well, number 1, there has to be a difference. What does the word difference mean in math?
Negative.
Subtract. So it has to have a subtraction sign in the middle. Doesn't have a subtraction, you can't do that. And then, are both of these 2 squares? Is something squared give you x squared? Yes, that's a perfect square. Is 4 a perfect square?
Yeah.
Yes, something squared, something multiplied by itself does give you 4. So now that you know this is difference of squares, you're going to do 2 sets of parentheses. 2 sets of parentheses. Since it's negative at the end, hopefully you realize what 2 signs would multiply to give you a negative. Both plus, both minus, or one of each? One of each. Has to be one of each. So 1 positive, 1 negative. What would x squared break into? X and x. So break it down. 1 goes into each. And what would 4 break into?
2.
2 and 2. Exactly. So break it down, x plus 2 and x minus 2. That's your answer. Okay, that's called difference of squares factoring.
What was the first one called?
The first one was just GCF. So this is GCF factoring, or greatest common factor. This one was squares. Technically, it's called difference of squares. Okay, so that was GCF. This is difference of squares. The next kind I want to look at for number 3 is I would like you to, again, factor completely 4 minus 16x squared. 4 minus 16x squared. 4 minus 16x squared. What kind of factoring do you think you could do here?
GCF.
What's a square?
What kind of factoring do you think we could do here?
GCF.
A lot of people say difference of squares, but first you always want to look for GCF. Okay? Does this have a greatest common factor?
Yeah.
What is the GCF?
4.
4. So yes, you do have to do GCF first. Okay, so first do GCF. If you divide away a 4, 4 divided by 4, what's left behind?
1.
A 1. You have to put in that placeholder 1. If you don't put the 1, it's going to be wrong. If you divide 16x squared by 4, what's left behind? 4x squared. Now, do you think you're done?
No.
No. Okay, on most of the problems that you're going to do for this unit, you will double, if not triple factor. Okay, so rarely you're actually going to be done after you factor the first time. So we took out a GCF. What's the next kind of factoring I could do?
Difference of squares.
Difference of squares. Okay. Now, don't forget, we still have to bring down this 4. Then we do 2 parentheses. Since it's negative in the middle, you do 1 with a positive, 1 with a negative. What does 1 break into? 1 and 1. So 1 breaks down to 1 and 1. What does 4x squared break into? 2x and 2x. So the actual answer here is 4 times 1 plus 2x times 1 minus 2x. Questions on how I did that? So it is totally possible and will happen a lot that you're going to double factor. You have to do it twice. Okay, that's why it says factor completely. Yes.
What kind of like jobs and stuff will this use?
Yeah.
A lot of you guys like to ask me, when will I use this in life? You probably won't, okay? But to be honest, the more you learn, literally, every time you learn a new concept, it makes a new pathway in your brain, okay? Like a new connection in your brain. The more pathways you have, the more connections you have in your brain, the more brain you're using, the smarter you are. Say it again? Actually, that's true. People that are higher educated have a lower incidence of getting Alzheimer's. That is true. That is true. Yeah.
So there's not a single job in the world that uses this math.
Oh, I'm sure there is. I just can't tell you at this moment what you would use factoring for. Yeah. I know that there is, but I personally do not know of any job thing. Oh, I'm sorry. If you become a math teacher, you will need to definitely know how to do factoring. Here you go. You asked.
Take a trip to Wilkie's room because she has the chart.
I know she has the chart. I keep trying to find the chart and I can't find the chart. Okay, number 4, x squared plus 4x plus 3. I need to just break down and buy the chart, but I don't want to spend money on
Or
it.
steal it from Wilkie.
X squared plus 4x plus 3. First thing you should look for is GCF. Is there anything that all 3 of these terms have in common? No.
They're all positive.
They are all positive, yes, but there's nothing that you can take out of all of these, except for a positive 1, which doesn't really help us. 3 terms means trinomial, okay? Whenever you have a trinomial, okay, I'm going to make kind of a little aside here, and I'm going to show you guys how to do the signs, okay? Signs for trinomials. Okay, we're going to come back to number 4, okay? Signs for trinomials, okay? If you have something squared, so we're just going to put an A there. That just means a number in front. Something squared plus something plus. So if all of your signs are positive, okay, if you have a plus in the middle, plus at the end, do you know what will that break down to? What kind of parentheses? What signs will be in there? Both plus, both minus, or one of each?
It could be plus.
Both plus, okay? If it's positive at the end, both of your signs in the parentheses will be the same as the middle. Okay? It also works for if I gave you something like this and you have positive at the end, but negative in the middle. Automatically, if you have positive at the end, both of your parentheses will be the same as the middle. So what would multiply to a positive, add to a negative, has to be 2 negatives. This is one of the things that people will mess up on the most. Okay? This is where the people have a lot of trouble. Now, if it's negative at the end, it does not matter if it's plus or minus in the front. Okay? Doesn't matter. Automatically, to get negative at the end, what 2 signs would you have to have in your parentheses?
Plus and minus.
One of each. Okay? It could be plus first or minus first, but automatically you will always have one of each. Okay? So that's the first thing you want to look at, is putting in your signs. So here, so this is something that, it's kind of an aside, but this is going to be kind of important to you because that's where people make the biggest mistakes generally, is with the signs. So if I go back to this one and I do 2 parentheses, what's going to multiply to a positive, add to a positive? It's plus at the end. They both have to be the same as the middle, I said. So what are your both your parentheses going to have?
Plus.
A plus, right. Now, some of you guys have done diamond factoring. Every teacher teaches it a little bit differently. So I'm not going to show you the diamond because, quite frankly, a lot of you can probably do it in your head. If you need to show the work, that's fine. The way that you would show this work is figure out what multiplies to give you 3.
1 and 3.
1 and 3. Is there any other options there?
No.
No. So what multiplies to give you 1 and 3, or to give you 3, excuse me, adds to give you 4? 1 and 3. This one is fairly easy. Okay, these are the only ones that will work. Doesn't matter which one you put in which parentheses because they're both have a plus in between. X squared breaks down to x and x. That's your answer, and you're done. Okay, that is the answer that I'm looking for there. Questions on how I did that? Okay, let's try another one. Number 5. I would like you to factor completely x squared minus 7x plus 12. X squared minus 7x plus 12. So this was called trinomial factoring. Automatically, the first thing you should look for is a GCF. Is there anything that all of these parts have in common? No. So if you look on your chart, it has 3 terms. So what's the only kind of factoring I could do here? Trinomial. That's the only kind. Okay? Break down your parentheses. If it's plus at the end, both the parentheses will be the same as the middle. So what would your middle signs be? Both negative. The x squared breaks down to x and x. Then you have to figure out what would multiply to 12 add to negative 7.
Negative 3 and negative 4.
If you don't see this in your head, you could write these down. 12 could either be 1 and 12, or 2 and 6, or 3 and 4. So you can kind of write your multiples on the side. Then you can hopefully see what would add to give you 7 is 3 and 4. Now, doesn't matter which one comes first because they both have negatives there. So x minus 3, x minus 4. If you flipped these, the same answer. Okay, it would mean the same answer, and that's fine. Anybody have a question on how I did that? Okay, let's try one more trinomial. I would like you to factor completely x squared plus 5x minus 6. X squared plus 5x minus 6. First thing you have to look for is GCF. Do these 3 parts have anything in common? No GCF. So set up 2 parentheses. What are your signs going to be? If it's negative at the end, you have to put 1 of each. So it's automatically going to be 1 positive, 1 negative. X squared breaks down to x and x. Now, this is where it gets a little bit tricky, okay? Here, what multiplies to 6? Either 1 and 6 or 2 and 3. If you know you're going to have 1 positive, 1 negative, which one can give you a 5 in the middle? The 1 and 6 or the 2 and 3?
1 and 6.
Has to be 1 and 6 because at the end here, you're going to have a negative. So if you know it's going to be 1 and 6, the way this works is the bigger number, so in this case the 6, always goes in the parentheses with the middle sign. So here the bigger number is 6, goes in the parentheses with the middle sign, which is positive. So x plus 6, x minus 1. Okay, the bigger number goes in the parentheses with the middle sign. Okay, that's kind of the rule there. Bigger number goes in the parentheses with the middle sign. I'll let you guys get caught up just in case I went too fast. Anyone still writing?
Just come there. Use the bathroom, please.
Mm-hmm. Okay, you guys let me know when I can move on. I have 3 more for you. Next one, for number 7. Again, I would like you to factor completely. Factor completely x squared plus 64. Factor x squared plus 64. Factor that completely, please. First thing you're always looking for is a GCF. So, is there any GCF here? No. Then, if you look at your chart, what's the only kind of factoring this could be? Or, well, there's 2, I'm sorry. Difference of squares or cubes, which we don't know yet, so I'm not going to have that on this worksheet. Is this a difference of squares problem?
Yeah.
What are the prerequisites for difference of squares? You have to have 2 squares, right? And these are 2 perfect squares. But do you have a difference in between them? No. This is not difference of squares. Does anyone think they know how this would factor? Any ideas? Let me show you what would happen if you did difference of squares. So difference of squares, don't write this part down. Difference of squares would be x plus 8, x minus 8. Do you understand how we would get there? Difference of squares, you do one positive, one negative. X squared breaks down to x and x. 64 breaks down to 8 and 8. If you FOILed this back through, or multiplied it back through, do you guys remember FOIL? F-O-I-L? First times first, or some of you might have done those boxes, okay? First times first would give you x squared. Outsides would give you minus 8x. Insides is plus 8x. Last is negative 64. What ends up happening here is these go away, but x squared minus 64. This is a plus 64. Anyone think they know how this would factor? Because it's obviously not x plus 8, x minus 8. Anyone have a guess? Do you think this factors? Am I leading to you to believe no? This does not factor, okay? This is something called prime. And basically what that means is it is not factorable, okay? This is prime. Generally, a lot of people try to make this, difference of squares is when there's a minus in between. Some people try to make this addition of squares. There is no such thing, okay? If you did x plus 8 and x plus 8, which is the biggest mistake that people would probably make, if you FOIL those together, first times first would give you x squared. You don't have to write this part down. Outside would give you plus 8x. Inside is plus another 8x. And last is plus 64. When these come together, you'd get x squared plus 16x plus 64. This obviously doesn't match up. Okay, so this one is not factorable. Okay, so we just call that prime. It's kind of like a prime number. Okay, do you guys know what a prime number is? Does anyone remember? What's a prime number?
47.
You're not giving me an example, but what does that mean? You just know some examples, okay? Something like a prime number is something like 17. Okay, prime means the only thing that goes into it is 1 and that number. So like 17 or 47, okay? The only thing that goes into those numbers is 1 and the number. Yes, good for you. Okay, let's try another one. So number 8. So prime is just another way of saying not factorable. Number 8, x squared minus 4xy minus 12y squared. X squared minus 4xy minus 12y squared. Now, does this have a GCF? No, there is not. Okay, a lot of people like to say the y, but there's not a y in that first part. Now, if you count up your number of terms, what kind of factoring would this be? Trinomial factoring. Now, there's a y at the end. That does not change anything at all about how you factor things. Okay, first I want you to put in the sign. So if it's negative at the end, what does that tell you about the signs? Is it going to be both plus, both minus, or one of each? It's plus at the end, or excuse me, negative at the end, Both plus, both minus, or one of each? Has to be one of each, because the only way you could get it multiplied to a negative is if you had one positive, one negative. That's the only way it works. Now, let's figure out, if you have a y at the end, y squared, all that means is you have to put a y at the end. Just like when your x squared breaks up, you have an x at the beginning. It does not change anything about how you do the problem, except that you just have to put a letter at the end. That's it. Now, to get the numbers, what would multiply to 12? Could be 1 and 12,
6 and 2.
or 2 and 6, or 3 and 4. Now, we know we have one positive, one negative. What's going to give you a difference of 4? 2 and 6. Remember, the bigger number, the larger number, goes with the same sign as the middle. So here, the 6 goes with the positive or the negative? The negative. Okay, 6 goes with the same sign as the middle. Larger number goes with the middle. So 6 goes with the negative, 2 goes with the positive, and you're done. That's your answer. Okay, let's do one more, then we'll be done. I'll let you guys have some time to do your work. I would like you to factor completely kx squared plus 3xk minus 28k. Kx squared plus 3xk minus 28k. So first thing you want to look for is a what? GCF. Is there anything that all of these have in common? A k. Take out the k, then divide that away. What's left behind is x squared plus 3x minus 28. So first we did GCF. Then what kind of factoring can I do? Trinomial factoring. So don't forget, you still have to keep that k on the outside. A lot of people tend to just lose the GCF on the outside. You do have to carry it down. So what would your signs be? If it's negative at the end, you're going to have 2 plus, 2 minus, or 1 of each. 1 of each, so 1 positive, 1 negative. What would multiply to give you 28? 1 and 28,
7 and 4.
2 and 14, 4 and 7. Any others? No? Which of these would give you a difference of 3? 4 and 7. And most of you guys don't have to show this step because you'll probably do it in your head. But if you need to, I would rather you show work than to, get it completely wrong. So where should the 4, where should the 7 go? Bigger number goes with the middle sign, so the 7 should go with the plus or the minus?
Plus.
The plus. 4 goes with the minus. X squared breaks down to x and x. That is your answer. Anyone have any questions? Okay, I'm going to give you guys new packets today, and you're going to be doing worksheet 1, numbers 1 through 30. You are just doing the odds. Okay, you are just doing the odds.
So 1 through 29 then?
So, yes, 1 through 29 odds. Thank you.